Wow, I probably look like crap. It's really warm in here, so that's not surprising. It's 81, something like that. So we got some pretty interesting things done on the F-15 today. Not a great deal of progress, but we got some stuff done. The scanner, it's a great piece of hardware. The software, it doesn't meet the needs I have. Let's just say that. I retried scanning the Avionics bay today by using that scan spray that I had, and I think I should have added tracking dots on top of the spray, but generally after about 90 minutes of scanning, I had what I felt was a pretty good scan. And when I started, they had a new update. It was 1.2.2.0, not a release candidate, just a release. I thought, yay, they got it fixed. And when I clicked on generate point cloud, it thought for about 30 seconds and then blue screened the machine. Yeah. No, you don't do that. So there's something about their software that's either reaching into kernel spaces it shouldn't or something and triggering a blue screen in Windows. And okay, that's fine, whatever. But when you lose all the scan data because you didn't save it first as part of the mesh process or the point cloud process, that's a problem. There is no ability to save your scan progress as part of clicking on the generate point cloud, which means 90 minutes worth of work is up in smoke. And I do not have the kind of time required to burn on quality assurance issues. So I took the other path and did everything by hand. So let's take a look at that. I decided that my original plan of leveraging the engagement pins at the back of each of these Avionics Bay tray locations wasn't really in my best interest for ease of installation. It was a nice idea, but there was enough outstanding issues that would make it more difficult to do the build than I wanted to. You can see, get my little pointer out here, you can see the holes. That's where those pins were, okay? And the pins look like this right here. It's kind of hard to see, but there's an alignment pin here, and then there's one all the way over there on the other side. But I went ahead and I removed those from all these three bays, and then this last bay over here. I then designed and 3D printed a little round jig. Okay, I got one here and one here. And the idea being is that I can use dowels to correctly identify the control rod path that was originally installed in the jet. And this is also going to be the same path that the belts are going to take. Anyway, what I did is I went ahead and I got one of the panels installed. And here, I'll do that real quick. Okay, so I've got my first servo mount there. And I used a square to measure from, or to not really to measure, not yet anyway. I brought the square up against this back face of the dowel, and then I made a little mark on the wood. And then I measure from the far edge of the mount, and then to that pencil mark, and then I added the radius of the dowel. And that gave me the center line for, in this case, that would be the pitch axis. Okay. And then I did the same thing for the roll axis. Okay. A buddy of mine that has a 737 flight deck showed me that technique when he was doing measurements for control cable runs on his simulator, and it worked out pretty well. So I'm going to go ahead and I'll drop in the other mounting plate. And these plates, I mean, they're 3/4 inch plywood is really all they are. One of the steps I need to take is I'm going to be measuring where I don't have underlying structure under here, you know, in this area here, and I will be drilling holes in there for bolts. And I haven't decided if I'm going to put threaded inserts in the material here and attach them from the bottom, or just use a flathead countersunk screw and a nut on the other side. But I'm always out from worrying about that. And then for this other side, I basically did the same thing. You know, the pins have been removed, and it's just a 3/4 inch sheet of plywood. This is where the belt return is going to be, and possibly the spring tensioners to hold tension on the belts. One of the interesting problems I run into is that the plane defined by this face is further away than the plane defined by this face. So it kind of makes it interesting to model correctly. I think I got it right, but we'll see. At any rate, I figured I'd use this as an opportunity to give you guys an idea as to what the configuration is going to look like. And man, these motors are not light. It's like 5 or 6 pounds a pop, I think. Anyway, so basically that is where the stepper drives are going to go. We got one there, and we got one here. Okay. One of the concerns I have is that which one should be first as far as this direction here, because there needs to be no interference in the belt paths. I think I'm okay, but I'm not sure. We'll see when I get more drawing done. I only have the basic geometry of the 3 mounts in place right now. So anyway, the idea is I have a servo here, and then I have my other gear. I think this is a 74 tooth gear or pulley or whatever you call it. And I think I talked about this before, but there's going to be 2 of these, one stacked on the other. One will be directly driven by the motor, and the second one will actually connect to the flight controls. Earlier in the week, I discovered that I had made a mistake when ordering my main drive belt. It turns out that it's too wide. The belt itself is 15 millimeters, and for the pitch axis mounting point right here, I have 12.5 millimeters. It's a 1/2 inch. And then on this side, I've got about probably a little bit more. It's actually 9/16 spacing between the two ears here, or mounting points. So I had to place an order for a new belt. Unfortunately, that's not going to be here until late July. In the meantime, I guess that just gives me more working time to get a good design refined down. I have not decided what the final form of that pulley is going to look like, or the pulley support, okay, for this thing, because you got one here, and we got one here. It's probably about yay. ish, that position, as far as what I'm going to use to support this. I don't know if I'm going to go with something 3D printed or maybe plywood or aluminum. I'm not quite sure yet. And it could be a mixture of the two. I don't know. At any rate, that's how I got my alignments done. And I'll also be able to measure from here to the underside of this, plus the radius, which will give me the Z height, or the Z height, that works, of the center line of the belt run. And that'll help me, again, with the geometry that I'm designing in Fusion. And then back here in this bay will be at least the return pulleys, okay? Because, you know, like this represents here, there's going to be a belt coming off of that, and it's got to come down and go back into the system. And I'm not quite sure what that's going to look like yet, because I am having some difficulty, again, with the positioning of this face versus this face and getting an accurate measurement. I may hold off on doing the final design of that component until I have both of these nailed down, and I can use their components to do actual physical markings and measuring on that plate to make sure that I've got my shit together for that. So there is my progress on the flight controls, or the force feedback stuff. This bay here, I removed the pins because this is where the power supply, or a power supply, if not just the one for the force feedback system, and the force feedback system's control board is going to live. So that's that. I wanted to answer a couple of questions I got about these things back here. In fact, let me get my fancy stick. These right here. These are air conditioning ports, okay? And you can see it feeds down into here, and then it terminates here because this has been, this has been removed, you know, years ago. But that is where the boxes got all of their air conditioning. And you can see down here, there's one over here and one over here, and these are all over the place. And then this right here is a heater tube. And this actually goes all the way up into the cockpit and is what provides hot air to the windscreen for defrosting and keeping it clear. And I think it's made out of titanium because it's all purpley and such like that. I don't think it became that color because of heat, because none of the zinc chromate behind it's been damaged or sooted up or whatever. Okay, so let's go take a peek at what I've been working on with the ejection seat. So this side of the seat is the original handle mechanism that came with it when I got it. It's currently still basically frozen because of rust and corrosion. And I'm working on one side at a time. But I wanted to show you some of the fiddling I've been doing on this side, okay? This is a new old stock F-15 style ACES 2 ejection seat handle. My problem is it doesn't fit. That's as far down as it goes, and it should be completely level with this top surface. And I've been picking at it with a 1/16 inch ball end mill stuck into a Fordham flex shaft moto tool. And I've been working on carving that out just a little bit to see how that would go. And the reason that I'm doing that is that, well, I mean, that's a real honest-to-God Aces 2 ejection seat handle. And I am struggling with the easy path of just taking this thing over to the grinder and grinding this piece out, or not out, but just grinding it back enough to the point that it'll fit. And I'm still waffling about that even as I grind away at this. I think in order to make the handle go completely flush, I'm going to have to take this down or open this up by around 1/4 of an inch. At least, because that's the impact point right there. It's not going to go down any farther than that. So that's maybe 3/8 of an inch, a little bit more, maybe 10 millimeters, something like that. And I don't know which would be the lesser sin. Carving up an original Aces 2 ejection seat handle, or making kind of an extreme modification to an Aces 2 training device, which effectively what this seat is. I don't know. I'm still on the fence about it. If any of you folks have opinions, I would love to hear them. So, leave me a comment. Let me know what you think. Let's go take a peek at what I've been working on with the Canopy bow. Okay, as you can see, this poor Canopy bow has seen better days. I have finally got all the components removed off of it. And all of them are bagged, and the indicators and mirrors are slated for a quick restoration job. I decided to not just transfer parts over, because the more I got into it, the worse the condition of some of the components became. Like this corrosion is just nightmarish. And there's even instances of them just dissolving entirely like this. So I decided that it would be in my best interest to make sure that none of the indicators had any damage like that, and to just go ahead and rebuild the entire wiring harness from scratch. In order to do that, I needed to order these steel clips because I didn't have any in the correct size for the task. And I needed some wire sheathing, or what the hell is it called? Wire wrap, basically. It's a mesh wrap. A lot of fancy PC builders use it. Anyway, so I think my next task is going to be to obtain some of these screw terminals that are for 440 thread screws, so I can put the indicators back. This is a lock shoot light position here and here, and this is the in-flight refueling light, and then the standby compass. I suspect this Canopy spent a lot of years outside, because the corrosion, or the level of corrosion, it was atrocious. And it could have been in salt air too, I don't know. Anyway, let's go ahead and take a peek at some of the bits that I pulled off. So here's the mirrors. Let's see, we have a left, a right, and a center, and the center mirror has got some pretty bad damage to it. And if you look at that right there, you can see that bracket is just torn. And I'm not sure how I'm going to go about resolving that. I think I'm going to talk to some of the wonderful folks on the 22nd TFS Facebook group and see if they have any suggestions beyond, well, this was just a field replaceable unit, we threw them away and replaced them. So yeah, I don't know if this is glass. I'd be surprised if it wasn't, but it might be, so I need to be super, super careful. I think if I just remove I think if I just carefully bend these tabs back I can take it apart, and if I can take it apart, I may be able to drill those rivets out and design a replacement bracket for that and bend up a new one and get it installed. We'll see. These are the lock chute light assemblies, and as you can see, the Air Force still loves its RTV or whatever compound they've got spread all over the back of these things. This is the ready light. Unfortunately, this thing is rusted really badly on the back here, so that's going to take some TLC to get that apart. I will take every effort to rescue that Cori indicator. And it's got some corrosion on the front that's damaging the paint, which means I'm going to have to strip this down and repaint it. And then here is the other lock chute light assembly. I went ahead and I haven't fully transferred it yet because I've got wiring that I have to run in through here. But this is part of the emergency canopy release section, or release arm. You can see it has a cable here on the bottom. And what you would do is you would, this is just a remove before flight pin, but if this wasn't here, you would pull this up, and what would happen is it would pull the canopy backwards a little bit. And that's important because of these right here. There's hooks that engage on both sides and in two different places. Okay, as you can see there, inside the cockpit. And that's one of the mechanisms that holds the cockpit closed in flight. And this cable runs through this duct. Excuse the horrible camera work. I'm looking at this upside down. It goes all the way back through and goes all the way out there into a tie point to a mechanism that I have yet not identified, but I probably will at some point. So yeah, and that's really all there is. Something you might find interesting. This right here is an air inlet port, okay? And what it is for is inflating the seal that is no longer present on the canopy. And what happens is when the closing mechanism pushes the canopy forward to lock it, a button is pressed right here. You can see where the paint's been rubbed off by the face of the button. When that button closes, air is run through this, okay, because there's a little metal bellows here in a rubber seal that comes against this, and it inflates the canopy seal to give an airtight seal to the cockpit. And I will show the front of it. You can see here that all the gasketing has been torn out. It's all gone. And I'll show you what it looks like on the other canopy, or on the canopy bow piece that I have here. And there you go. This is part of that seal. And you can see it goes down all the way through. It goes all the way around, down the other side, down the other side of the cockpit. So I think that's going to be it for this update. Thanks for watching, and I look forward to showing you more soon. I'm going to record this just because I think it's a neat view. Very slick.